Two lawyers in New York got fined $10,000 because his AI made up 6 fake court cases. Students have turned in papers citing books that literally do not exist. People have received AI-generated medical advice that contradicted their actual prescriptions. And here's the part that should genuinely unsettle you. The AI that did all of this was not broken. It was working exactly as designed. Because every AI you've ever talked to, ChatGPT, Claude, Gemini, all of them, this is built on one trick that sounds so dumb you'll think I'm joking. It guesses the next word. That's it. The most powerful technology of the last decade is, at its core, autocomplete on a budget of billions of dollars. But stay with me, because by the end of this video, you'll understand why that stupid simple trick accidentally created something that can write poetry, pass bar exams, and code entire apps. And you'll understand why the people who built it aren't entirely sure how it does any of those things. That part comes later, and honestly, it's the part that keeps AI researchers up at night.
Okay, so before we get into the wild stuff, let's build this from the ground up. What actually is a large language model? Picture this. You have a friend who has read every single thing ever written on the internet. Every Wikipedia page, every Reddit argument, every medical journal, every trashy novel, every terms of service agreement you've never read. They absorbed all of it. Not the facts exactly, but the patterns. The rhythm of how people put words together. How a legal document sounds versus a love letter versus a YouTube comment at 3 in the morning. Now imagine this friend has never been outside, never tasted food, never felt embarrassed or excited or bored. They've only ever read about those experiences, millions of times over. That's an LLM, a machine that got so good at recognizing patterns in text that it can finish almost any sentence you start. Be honest, would you trust that friend? Someone who's read everything but experienced nothing? Drop your answer in the comments because I'm genuinely curious what people think. And the amount of text we're talking about is genuinely hard to wrap your head around. GPT-3, which is now considered small, was trained on about 500 billion word fragments pulled from 45 terabytes of raw internet text. That's more than any human could read in 1,000 lifetimes. Today's models? Way more. But here's the thing that makes the whole system work, and it's the part most people skip. The machine doesn't actually read words. Computers can't process letters, they process numbers. So the very first thing an LLM does is chop your sentence into little pieces called tokens and convert each one into a number. Sometimes a token is a whole word, sometimes it's a chunk of a word. Understanding might become under and standing. The word artificial might get split into art, ific, and isle. Each piece gets a numeric ID badge. And from that moment on, the model isn't dealing with language at all, it's doing math. Now, here's where it starts to get genuinely cool. Those numbers don't just sit there like a list. They get placed into an enormous invisible map. Imagine a space with not 3 dimensions, like the room you're in, but thousands of dimensions. Each word lands at a specific spot in that space based on what it means. And words with similar meanings cluster together. Happy ends up near joyful. Cat ends up near kitten. Terrible sits right next to awful. Nobody programmed those relationships. The machine figured them out on its own by noticing that those words tend to show up in similar sentences. And that still blows my mind, honestly. It learned what words mean just by reading enough to see the patterns. Alright, so we've got words turned into numbers, mapped into a huge invisible web of meaning. Now what? Now we get to the invention that changed everything, and it came from a paper with possibly the greatest title in the history of science. In 2017, 8 researchers at Google published "Attention is All You Need." That paper has been cited over 173,000 times. Every major AI system you've ever used runs on the architecture they described, the transformer. But remember that thing I mentioned earlier about AI researchers losing sleep? We'll come back to that. First, you need to understand what the transformer actually does. Before the transformer, language models read text one word at a time, left to right, sequentially, like reading a book with a terrible memory. By the time the model reached the end of a long paragraph, it had basically forgotten the beginning. Important context just evaporated. The transformer destroyed that limitation. It reads every word in a sentence simultaneously, and then it asks one very powerful question. For each word here, which other words should I be paying attention to? Think of it like being at a noisy dinner party. 12 people are talking. You're not giving everyone equal focus. When someone says your name, your ears perk up instantly. When someone starts telling a story, your attention shifts. You're constantly, unconsciously deciding what matters in the conversation right now. The transformer does exactly that, except it does it from multiple angles at once. Multiple heads of attention, each one tracking a different type of relationship. One head might track grammar, another might track meaning. Another might figure out that it in a sentence refers to the cat mentioned 6 sentences ago. All happening in parallel, all at the same time. And this is the engine. The attention mechanism is the reason AI went from a nerdy research project to the thing your mom uses to write birthday cards. It's that important.
Quick thing. If this is making sense so far, hit subscribe. We explain how the world actually works, and we do it without making you feel like you need a computer science degree. All right, back to it.
So how does the model actually learn all this? Here's the part that sounds like a joke, but isn't. You show the machine a sentence with the last word removed. The dog chased the blank. It guesses. It gets it wrong. You tell it the correct answer. It adjusts slightly. And then you do that again. Billions of times. Trillions of times. Each wrong guess triggers tiny adjustments to billions of internal settings called parameters. Think of parameters like the dials on a massive mixing board with hundreds of billions of knobs. Each adjustment is microscopic. Almost nothing changes. But after trillions of rounds, something unexpected starts happening. The model doesn't just learn word patterns. It starts picking up logic, cause and effect. The idea that if someone walks into a room holding an umbrella, it's probably raining outside. Nobody programmed that inference. Nobody coded a rule about umbrellas. The model just saw enough examples to connect the dots. And that's the thing that scares the researchers. These behaviors, solving math problems, writing code, reasoning through multi-step logic, none of it was explicitly trained. It emerged, spontaneously, as a side effect of predicting the next word at enormous scale. Which is, when you sit with it for a second, kind of terrifying and kind of beautiful at the same time. Now here's a question that should be forming in your head. If the model learned everything from the internet, didn't it also learn all the garbage? The conspiracy theories, the wrong medical advice, the toxic comment sections? Yeah, it absolutely did. And that's why there's a whole second phase of training that most people don't know about. After the model finishes its massive reading binge called pretraining, it goes through something called reinforcement learning from human feedback, RLHF. And the concept is weirdly intuitive. Human reviewers give the model a question. The model spits out 2 possible answers. The human picks the better one, not based on some formula, just vibes. Which answer is more helpful? Which one is less likely to give someone dangerous advice? Which one actually answers the question instead of going on a tangent? Those human preferences, thousands of them, train a separate model that learns to predict what humans would rate highly. And then the original model gets nudged toward producing responses that score well. It's like teaching a golden retriever, except this golden retriever has 500 billion parameters and can process an entire library in seconds. Reward the good behavior, gently discourage the bad. And over time, the model transforms from a chaotic text generator into something that sounds like a thoughtful, helpful person. By 2025, this was standard at every major AI lab. And it's why the ChatGPT you use today sounds nothing like the version that launched in late 2022. Same bones, completely different personality. Now, the cost, because nobody in this industry loves talking about this part. Training a single model like GPT-4 consumed an estimated 50 gigawatt-hours of electricity. That's enough to power thousands of homes for a year. And that's just the successful run. The failed attempts cost just as much. Then there's inference, the energy used every time someone sends a message. One query uses about 1/3 of a watt-hour. Tiny. But multiply that by 1 billion queries a day, and the annual energy bill exceeds what 35,000 American homes use in a year. Just for people asking AI to summarize emails. And after all of that cost, all that training, all those parameters, the model still makes stuff up. Confidently, with a straight face. They call it hallucination. The AI will cite a study that was never published, invent a person who never existed, give you directions to a building that burned down a decade ago. And it delivers all of this with the same polished certainty it uses when telling you something true. Why? Because the model can't tell the difference. It's predicting the next word. It doesn't have a fact-checking engine running in the background. There's no internal database of truth it's consulting. If the most statistically likely next word is wrong, it types it anyway with full confidence. In 2026 benchmarks across dozens of models, hallucination rates ranged from 15 to 52% depending on the task. For medical summaries, that number spiked above 60%. I want to know, what's the wildest thing an AI has ever confidently told you that turned out to be completely wrong? Put it in the comments. I read every single one, and some of them are absolutely unhinged. And here's the kicker. Some researchers now believe hallucination might not be a bug at all. It might be a fundamental consequence of how prediction-based systems work. The very feature that makes them creative also makes them unreliable. And that brings us back to the thing I promised earlier, the part that keeps researchers up at night. Does this machine actually understand anything? In 2021, a team of researchers coined the term stochastic parrot, arguing that LLMs are basically just repeating word patterns without any real comprehension. Like a parrot saying, "Polly wants a cracker," with no concept of crackers or wanting. But then you watch one of these models solve a logic puzzle it was never shown, or translate between two languages it barely saw during training, or draw an analogy between quantum physics and jazz improvisation that actually makes sense. And just a parrot starts feeling like calling the ocean just some water. In 2025, researchers at MIT found that large language models organize completely different types of information: text, code, math, images, using shared internal structures that look eerily similar to how the human brain handles diverse inputs. Something is happening inside these networks that goes beyond simple pattern matching, something structural, something deep. And we built these things. We designed the training, we wrote the code, and we genuinely cannot fully explain what's going on inside them. So here's the million-dollar question, and I want your honest take in the comments. Do you think AI actually understands what it's saying? Or is it the most convincing parrot the world has ever seen? There's no wrong answer. Even the experts can't agree. That's the part that keeps people up at night.
We built the most expensive autocomplete in human history. We fed it the entire internet. We taught it to guess the next word. And then we watched, stunned, as it started writing sonnets and passing law exams and explaining quantum mechanics in the voice of a pirate. All from prediction. All from patterns. All from a trick so simple it sounds like it shouldn't work at all. The next time you type a question and get a perfect answer in 2 seconds, remember, a machine just ran billions of calculations. I have consulted the ghost of every book and web page it ever absorbed, and placed a statistical bet on which word should come next. And it did that hundreds of times. Just for you. So that's all for today. I hope you have enjoyed this video. Thank you so much for watching, and don't forget to watch our videos.